We read a bunch of poetry.
Okay, so taking the last warm-up question as a cue, what do we get? What do we use here? Because we're supposed to find the current through the external resistor. Okay, so the total EMF, or the total resistance, I'm guessing should be around 20. So that should be straightforward. And if we're spinning this through this, then we should be able to get a certain amount of EMF. So what's the equation again? We just wrote it down, so we should know this. Oh, whoops, it's omega NBA sine omega t. Now this is easy because they asked for the max current. So what does that got to be? 1. Bing. That's easy. Okay, because that's got to be the max current. Any other time the current's going to be less than that. So now it's just a function of plugging everything in. Because that's 50 radians per second. I think, did they say 3 turns? Yeah, 3 turns. I should have written that here. This is 0.2, and the area, we have to look at it and see that it's 0.3 times 0.2, so that gives you, what, 0.06? And then just multiply all that together. So, what? This times that gives you 10. That times that gives you 0.6. That times that gives you 1.8. 1.8 volts. Now that's not the answer. That's what we need to get the answer. Because then I is going to be the EMF over the total resistance. Because of whose law? Ohm's. Right, Ohm's law, V equals IR. So I is V over R, or EMF over R. So we get 1.8 volts over 20 ohms, and then what's that going to get us? 0.9 over 10, so that's going to be 0.09 amps. But that's in my head, so that could be wrong. Check the mass.